Welcome back to the GCSE Maths Pro YouTube channel. Today's video is part 2 of the completing the square topic, where we'll be looking at how to complete the square but for harder quadratics. This is where we might have a number in front of the x squared, for example 2x squared, 3x squared, so on. Make sure you've checked out the first video on completing the square just so that you know the basics of the method, and then come back here to see how we apply it to harder quadratics. As you can see, this is a higher tier topic only, so if you are foundation, you don't need to pay any attention to this. So let's jump right into it. As I said, we've already gone through how to complete the square in general, okay? So if you're looking for a more in-depth explanation, please go back and check out the first video. Now we're applying it to a harder quadratic. As you can see here, we now have 2x squared, not just 1x squared. So write 2x squared plus 8x plus 5 in the form a brackets x plus b squared plus c, where a, b and c are integers. So if you've seen the first video, you can tell that we have a very similar format here. Obviously this is still completing the square format. However, we now have a number on the outside of the brackets first, before we then have the same format afterwards. So you can see this bit looks familiar. However, now we have this extra a on the outside. So there are 3 numbers we need to figure out. So it's the same method, the only thing that's different is we're going to add in an extra step at the start. So before we begin, you can see that in the brackets we still only have x, okay? So we want to separate out the number that's in front of the x squared first. So what I'm going to do is factorize my quadratic. Now again, there are 2 ways to do this, but I'm just going to show you the way that I prefer. I'm actually going to only factorize the first 2 terms. So what I mean by that is I'm going to pull out the 2, because I only want x squared, and I'm also going to pull it out of the 8x. So 8x divided by 2 is just 4x, close the brackets, and I'm going to leave the 5 on the outside, okay, so that doesn't need to be factorized. Okay, the 2 is going to be our a, basically. Now from here we can start our completing the square method. So just keep the 2 there for now, and I'm going to use square brackets just for now. And you remember that we said, right, in the brackets we've got x, you copy the symbol, which is plus, and you half, or you divide this term here by 2. Okay, so the number that's in front of the x, you divide it by 2. So that becomes 2. So we've effectively divided it by 2 twice, haven't we? Only because this one on the outside of the x squared was a 2. Sometimes it might be a 3 or a 4 or whatever, but then we half it. So always make sure you write out this step first, because I think it can be quite easy to forget that the 8 needs to be divided by 2 because of this 2 on the outside, and then also halved because of the method. So we've got our x plus 2 squared, and you remember that when we did our first video we said, right, then you have to subtract this term squared. So I'm going to subtract 2 squared, which is 4. I'm going to close my square brackets. I still have plus 5 on the outside. So you can see this does get a little bit complicated. We've got a few different brackets. Then what I'm going to do is, because can you see that my actual format doesn't have these square brackets? So I'm going to expand out 2 again, however, obviously leaving my squared brackets the same. So what I mean by that is we're going to have 2 bracket x plus 2 squared. So it's effectively like I've done this. And then you also have to then do 2 times this minus 4, which becomes minus 8. And we still have the plus 5 there. And the last bit is just doing minus 8 plus 5, isn't it? So you've got 2 x plus 2 squared minus 8 plus 5 is minus 3. There we've got a, b and c. You can see a is obviously 2, b is also 2, and c is minus 3. Okay, it's a lot to take in. As I said, I'm going to keep repeating this. If you're not happy with completing the square in the first place, you have to watch that video and then come here to see how it's applied to a harder context. Let's just keep practicing, and hopefully after a while you can see the pattern of the steps. So we're going to do the same again. Before I start completing the square, I need to pull out this 2. Now I know you can factorize 2 out of everything here. You can technically do that. You kind of end up having to factorize out of 6 and then having to times it by 6 again, so it's kind of a bit pointless in my eyes. I just factorize whatever the coefficient, and the coefficient is the number in front of whatever we're referring to, so the x squared. The coefficient of x squared, I factorize it out of the first 2 terms. So I'm going to pull out the 2. Brackets, x squared, obviously minus 12x divided by 2 is 6x, and leave the plus 6 there just for now. So that's not completing the square, that's just factorizing, isn't it, into single brackets. Then I'm going to complete the square of this middle part. So leave the 2 where it is. I'm going to use square brackets because technically I end up with two lots of brackets, don't I? I create my squared brackets here, so I get x, copy the same symbol, which is minus, and half this term, so 6 divided by 2 is 3. Okay, then to remember how we said, right, whatever this term is, we have to square it and subtract it on the outside of the squared bracket. So 3 squared is 9, so I'm going to subtract 9, close my square brackets, and I've still got the plus 6 there. Then I just want to get rid of the squared brackets, don't I? So multiply the 2 by this set of brackets here and by the 9. So I've got 2 x minus 3 squared in brackets. 2 times minus 9 is minus 18 plus 6. And now all we have to do is do minus 18 plus 6, isn't it? So 2 x minus 3 squared minus 18 plus 6 is then minus 12. And there you go. A is 2, B is minus 3, and C is minus 12. Okay, so as long as you can try and remember this method, it should work every single time. Okay, so we're going to do the exact same thing again. So write 2x squared plus 10x minus 7 in the form A, brackets x plus b squared plus c. So, as I said before, we're going to start by just factorising out the coefficient of x squared. The coefficient is just the number in front of, in this case, x squared. 10 would be the coefficient of x, for example. So the coefficient of x squared is 2. So you factorise that out. I would just factorise it out of the first two terms. That's what I prefer to do. So I've got x squared plus 5x, and then minus 7 is just still on the outside. Now I'm going to start to complete the square, so I need to keep my 2 on the outside. I'm using square brackets because I end up with double brackets, and obviously putting 2 brackets like this looks a bit odd, doesn't it? I'm just using square brackets to make that really obvious. So completing the square for the x squared plus 5x. Well, we know we have to put an x. We know we copy the symbol. And then we know that we have to half this coefficient of x, which is now 5, so 5 over 2. So this is where it gets tricky again, because it's not an even number. So when we divide it by 2, we don't get a whole number. Okay, squared. So as I said in the previous video, you can either put it as a fraction or you can use a decimal. I would say personally it depends on if if it's a calculator test or not. If it's a non-calculator, I would use fractions. So I'm going to show you the non-calculator way, just so that you know. But if it's a calculator test, then just chuck it in the calculator and use decimals, however you prefer. Okay, so completing the square, we put it in the brackets, but you remember we had to then subtract this term squared, didn't we? And as we said in the first video, the way that we square fractions is we literally just square the top number and the bottom number. So we get 25 over 4. Close the square brackets and we still have minus 7 on the outside. Now I need to get rid of those square brackets because as you can see I don't have them in my actual format, so I'm going to multiply both of those terms by 2. Obviously I'm not expanding the squared brackets, I'm just getting rid of my square brackets. That's actually doesn't make sense, that the squared as in the squared symbol, but then square brackets. I'm just trying to get rid of these square brackets, but I'm not going to be expanding the rounded brackets that are squared. That definitely doesn't make any sense, but hopefully you get the gist by looking at what I'm doing. So I've got 2 and then the normal brackets, x plus 5 over 2 squared. Now, I then need to do 2 times 25 over 4, don't I? And like I said, if you have a calculator, no problem. Some people aren't really sure how to multiply a whole number with a fraction. Basically, it just means you have to multiply the numerator. Because a lot of people think, oh, I just have to double the numerator and the denominator. Well, no, because if you times both of those by 2, the fraction hasn't actually changed, has it? I know it would be 50 over 8, but it would still simplify to the same thing. So it's not being doubled, has it? So only multiply the numerator. The reason being is, again, in our first video, we mentioned how any whole number can be written as a fraction if you just put over 1. Because 2 over 1 is just 2, isn't it? And then if you think about how do I normally multiply fractions, I multiply across, don't I? So for example, 2 times 25 at the top is 50. But the denominator would be 1 times 4, which is still 4. Okay, so that's my point, is if you're multiplying a whole number with a fraction, just multiply the numerator by that whole number. Now, before I put this back, I might simplify that because 50 over 4 can be made into 25 over 2, can't it? Just so it's smaller. Okay, so I've then got minus 25 over 2, and I've still got the minus 7. Now, the last bit, which again you will have seen in the first video, is that if we don't have a calculator, adding and subtracting fractions, they need to have a common denominator, don't they? So first of all, 7 is not only not a fraction currently, but also needs to have a denominator of 2. So 7, as I said, any whole number you can write as itself over 1, so 7 over 1. However, we want the lowest common multiple of 2 and 1, which is obviously 2. So I need to multiply not only the bottom by 2, but also with fractions, whatever we do to the top, we do to the bottom if we're changing them like this. So 14 over 2. Now, obviously 14 over 2 is just 7, isn't it? That's the whole point. It's an equivalent fraction. So I'm going to rewrite it again. Minus 25 over 2 minus 14 over 2. Now I can actually subtract these, can't I? When we subtract or add fractions, we only subtract or add the numerators. Okay, so we have a bit more space now. So our final answer, we get 2 on the outside, open bracket, x plus 5 over 2, close bracket squared, minus, and then we've got, obviously we still got over 2, minus 25, take away another 14 would be minus 39, wouldn't it? So minus 39 over 2 on the outside. So that's our final answer, and I can't simplify 39 over 2 because 39 is an odd number, isn't it? It won't divide by 2. So there is your final answer. Okay, so what can happen is that in the exams, you might think, yeah, I'm great at completing the square. This is all really good. Even harder completing the square like this. However, if they then throw in some where you've got fractions and you don't have a calculator, a lot of people get stuck on that bit. So they're fine with the grade 8, grade 9 stuff, but they can get stuck on the fractions, which is obviously, I don't even know what grade that is, maybe 1, 2 or 3. So make sure you're really happy with fractions as well, because that can happen a lot, not just with completing the square, but it can come up in a lot of other topics on the non-calculator paper when you didn't expect it. Okay, let's try this one. So now we have got a 3x squared. So we've got, right, 3x squared minus 24x minus 11 in the form a brackets x plus b squared plus c. So we're still doing the same thing. I'm going to factorize out the coefficient of x squared, which is 3. So I get x squared in the brackets minus, and obviously 24x divided by 3 is 8x. Now I'm going to only factorize those first two terms, so leave the 11 on the outside. Then we've got our square brackets, because now I'm going to actually complete the square. So we've got x, copy the same symbol, which is minus, and then half of 8, luckily is 4, it's a whole number, squared. And then remember how we have to subtract this number squared. And as we said before in the other video, it doesn't matter if it's minus 4 or 4. If you square it, it's still going to be positive 16, isn't it? So I'm subtracting 16, close my brackets, minus 11 is still there. Now I want to get rid of the square brackets. So I've got 3 multiplied by my normal brackets, that's a better way to say it, x minus 4 squared, and then 3 times by minus 16, which is minus 48. Still have our minus 11 there. And these we just have to subtract, don't we? So 3 x minus 4 squared, and then minus 48 minus another 11 is minus 59. There you go, A, B, and C. So that one was much nicer when there weren't any fractions involved. Okay, pause the video, try this one out yourself. As you can see though, it's a little bit trickier because we've not only got x squared, we've got a negative x squared. But let's go through it together. So in this case, as I said, we're going to factorize out the coefficient of x squared. Now that's 4, yes, but I'm also going to factorize out the negative. Okay, so I'm factorizing out negative 4. Not only because having positive x squared is just easier, but also do you see how in the brackets over here we've got x? It's not negative x, is it? So I'm going to factorize out the negative 4. So remember, not only does that mean I'm dividing everything by 4, but I'm also then going to change the symbol. So for example, we've got positive 16x. Obviously divided by 4 would give me 4x. However, positive 16x divided by negative 4 makes it a negative, doesn't it? So be really careful with that. Otherwise, it's the same. We still have our minus 6 on the outside because I haven't factorized that. And now I can go ahead and complete the square. So open my square brackets. X, copy the symbol, minus, and then 4 divided by 2 is 2. So luckily another whole number. Now 2 or minus 2 squared is 4 either way, isn't it? So subtract the 4, close my square brackets. I still have minus 6 on the outside. Now I'm going to get rid of my square brackets. So I've got minus 4, x minus 2 in my normal brackets squared. Now, minus 4 times minus 4 is then plus 16, isn't it? Okay, and then we still have our minus 6. Now we just tidy up the last bit. So minus 4 in the brackets x minus 2 squared 16 minus 6 is plus 10. There we go. So even if there's a negative there, it's still very straightforward. Just be really careful that you might have to flip some of the symbols, okay? Okay, this is our last question. Again, as you saw in the first video, we've just written it slightly differently. However, still the same thing. So given that minus 5x squared minus 5x minus 9 equals a brackets x plus b squared plus c, find the values of a, b, and c, basically. So pause the video, try something out yourself, okay? As we said, don't just take out the 5, take out the negative as well. So let's go through this. I'm going to factorize out minus 5 because I want a positive x squared ideally. So in my brackets I get x squared. Obviously then minus 5x divided by minus 5 is just plus x, isn't it? Okay, plus 1x. So be careful, that does change the symbol there. And we still have minus 9 on the outside. Then I'm actually going to complete the square. So I'm opening my square brackets, minus 5 on the outside. In my normal brackets, I've got x, copy the symbol, plus, and this is technically 1x, isn't it? So when I half it, I get 1 over 2 or 1/2. You can put 0.5 if you like, as I said before, but it depends if you have a calculator or not. And then I have to subtract the half squared. So as I said, when you square fractions, you just square the top and the bottom. So 1 squared is 1, 2 squared is 4. So it comes out as a quarter. Close the brackets, minus 9 is still there on the outside. I want to get rid of my square brackets now, so I've got minus 5 multiplied by just the normal brackets, which was x plus 1/2 squared. Then I need to do minus 5 times minus a quarter. So first of all, that's going to become a plus, isn't it? Negative times negative is a positive. And as we said before, if you've got a whole number multiplied by a fraction, you just multiply the numerator, because technically 5 is 5 over 1, isn't it? So 5 times 1/4 is just 5 over 4, 5 quarters. Okay, so I've got plus 5 over 4 and still minus 9. And now we need to add these together. And again, if you don't have a calculator, we need to make the 9 into a fraction with a common denominator. So I can make it 9 over 1. And the lowest common multiple between 1 and 4 is obviously 4. So I need to times the top and the bottom by 4. 9 times 4 is 36. Obviously, if you were to simplify that, 36 divided by 4 is 9. That's fine. We want it to be the same thing. So I've got minus 5 on the outside, x plus 1/2 squared, and then we've got plus 5 over 4 minus 36 over 4. Now we've got some more space. We can actually, well, in this case, subtract them, can't we? And when we subtract fractions, we just subtract the numerators. The denominator is still the same, so we've still got over 4. So 5 take away 36 is going to make it negative, isn't it? Negative 31 over 4. And as 31 is not an even number, I can't divide it by 4. So that is as simplified as you can get. So there you go. It says find the values of a, b, and c. So a is minus 5, b is 1/2, c is minus 31 over 4. Just be careful, because as you can see here, I put all pluses, so therefore I have to specify that a is minus and c is minus. If they had, let's say they'd written, for example, minus a and then x plus b squared minus c, when it says find a, b, and c, you wouldn't obviously write the negatives because they've already written the negatives. So just really double check, do I need to write my negatives or not? In this case, the way that I wrote it, yes, we do. Okay, so that's everything on completing the square for harder quadratics. Now that we know how to complete the square, the next video is a really short one just on how to solve quadratics by completing the square. But the more important one to look at, once you've checked the next one, is the last one. This is really important. So finding turning points of quadratic graphs by completing the square, because that's a really easy extra mark to get. If you can already do the completing the square bit, which is the harder bit, you'll be able to find the turning points. So make sure you check out that video specifically. So thanks for watching this video, and I'll see you in the next one.